So today we will study about classification of organic compounds. What are organic compounds? These are the compounds that consist of the carbon as an essential element and also hydrogen with it, okay? It's not like they consist of only carbon and hydrogen, they also consist of some different heteroatoms like sulfur or carbon, nitrogen. Some other atoms also can present in these compounds, but essentially they must consist of carbon and hydrogen. So these organic compounds, basically they are classified into two types depending on the structure, okay? So one is open chain organic compounds, the other is closed chain organic compounds. Closed chain organic compounds are further classified into two types, homocyclic and heterocyclic. Homocyclic is again classified into two types, alicyclic and aromatic. Aromatic is further classified into two types, benzenoid, non-benzenoid. The same kind of classification will be there even in the case of heterocyclic, like they are also classified into alicyclic aromatic and again benzenoid and non-benzenoid. So this classification is mainly based on what? This classification is done based on the structure of the organic compounds. Like the given organic compound may have open structure, then it comes under open chain category. If it is having rings like cyclic structures, then it comes under closed chain. So again in this closed chain, if the ring is having all carbon atoms connected, then it comes under homocyclic. If some different atom is also present in the chain, then it comes under heterocyclic. So like this, the organic compounds are classified based on the structure. Now we'll discuss one by one. First we'll discuss open chain, then we'll go for closed chain, and again homocyclic, heterocyclic. We just discuss one by one, okay? So first we'll discuss about open chain organic compounds. So as the name itself gives us the answer, open chain, that structure is open. When we observe the structure of these organic compounds, their structure will be open. So they have open structure. So what is the meaning of open structure? It means that it doesn't have any rings in it. No rings in the structure, okay? And these open structures may include linear structures, also branched structures. It must be open, that's it, okay? It can be linear, it can be branched. And even it may be saturated or it may be unsaturated. Like in the open compounds, carbon to carbon, it may have single bond, or even we may observe double triple bonds also. Can be saturated, can be unsaturated as well. Saturated means what? Carbon to carbon we observe single bond. Unsaturated means there are two possibilities, carbon to carbon double bond and carbon to carbon triple bond. It can be any of this, both come under unsaturated. Like let me take an example. I'm just taking first example. I'm taking N-butane. What is this compound? This is N-butane. Now how is it? It's open structure and it's linear and it is saturated, isn't it? So when we take a discussion of this compound, it is open compound. So it is having open chain structure first of all, and it is having linear structure, and carbon to carbon we are having single bonds. So this is a saturated compound, okay? Now we'll discuss few more examples for open chain compounds so that you'll be clear with this topic. So here are few more examples. So let us understand what kind of compounds are these, okay? So observe example 2, example 3 and example 4. So we'll start with example 2, which is isobutane. So if you see here, it's an open compound, and if you see its structure, So this is open chain compound, first point. And second thing, it's branched, right? It's not linear, it is having a branch. For suppose if I consider this as a parental chain, at second position I have one branch which is called methyl group. So this is a branched compound. And when we observe the kind of bonding between carbon atoms, it's all single bonds. So this is a saturated compound. Now let us come to example 3. So this is also an open chain compound because there are no rings in it. And what kind of open chain compound? Linear or branched? It is linear because we have only one parental chain and there are no other branches in it. Okay. And if you see the kind of bonding between 1 and 2 carbon atoms, we are having double bond. So if double bonds are present, it comes under what kind of compound? Unsaturated compound. Now let us come to example 4. So example 4, there are no rings in it. So this is also an open chain compound. Now linear or branched? It is having branches, right? So if I go with the parental chain, it is having 4 carbon atoms, and the above at third position we have 2 branches, that is methyl groups. So branches are present, so this is having branched structure. And if you see between 1 and 2 carbon atoms, there is a triple bond. So it's an unsaturated compound. So this is how we have to consider the kind of organic compounds. No rings, so open chain. If it is having only parental chain, no daughters in it, then it becomes linear. If side chains are also present, it becomes branched. And depending on the type of bonding, singular, double or triple, we just classify them into saturated and unsaturated. I hope you are clear with the first category of classification of organic compounds, that is open chain. Okay. Now we will see cyclic compounds. So second category, that is closed chain organic compounds. So as I had discussed in the very beginning, closed chain organic compounds will be having rings in them. Okay, so these compounds will contain rings in them. Okay, rings are present. Now just understand logically, to form a ring, minimum how many carbon atoms are required? Like if you take one carbon atom, it's not possible to form a ring. And even with the case of 2 carbon atoms, if you take 3 carbon atoms, so minimum 3 carbon atoms are required. 3 carbon atoms are minimum to form a ring, isn't it? Minimum 3 carbon atoms are required. Like you can take cyclopropane, cyclobutane. The cyclic compounds will form with minimum 3 carbon atoms. With 2 and 1 carbon atom, it is not possible. Okay. Now this closed chain compounds, they are also called cyclic compounds. Okay. What do we call the open chain compounds? I'll just write a note point here. You just mention where you have written that open chain compounds. Okay. Open chain compounds are having different names. Open chain compounds are also called acyclic compounds. Acyclic. Cyclic means will be closed. Acyclic means they are not having closed structures. So they are also called acyclic compounds. And they are also called aliphatic compounds. So these are the other names for open chain compounds. Now when we see closed chain compounds, they are also called cyclic because they are having rings. Acyclic means no rings. Okay. Now, so closed chain compounds, as I have discussed, these are further classified into how many types? Homocyclic and heterocyclic. We'll discuss that a bit later. Now in the given molecule, if we find only one ring, it is said to be monocyclic organic compound. And if we find more than one ring, this is greater than symbol, which means more than. Okay, it will be considered as polycyclic. Like for suppose 2 rings are present, bicyclic, 3 rings are present, tricyclic. So simply what do we do is, more than one ring we will consider it under polycyclic compounds. So this is classified based on the number of rings present. Based on the number of rings present in the given molecule, they are classified into monocyclic or polycyclic. Okay. Now we will see the further classification of closed chain compounds, that is homocyclic and heterocyclic. First we will discuss homocyclic. homocyclic organic compounds. See, homo means same, cyclic means closed structure. So in the cycle, the connecting atoms will be same. That is the meaning of homocyclic. And which will be the connecting atoms here? Carbon atoms. Okay. So in ring, the connecting atoms will be whom? The connecting atoms will be carbon. For suppose when I take this is what? This is cyclopropane. Now if you see here, all the connecting atoms in the ring or what? In the ring or carbon atoms. I can also write like this: CH2 connected with CH2 connected with CH2. So this is how it is connected. So if you see the bonds here, the bonds are formed between carbon atoms. So in the ring, the bonds are connected with all carbon atoms only. So such kind of organic compounds are homocyclic. Homo means same, all carbon atoms in the cycle. Okay, such kind of compounds are homocyclic organic compounds. Exactly opposite. Like in the ring, if some different atoms are also present, then it comes under heterocyclic organic compounds. Okay. So as I said, these homocyclic organic compounds are classified into how many types? They are classified into two types. One is alicyclic homocyclic organic compounds, aromatic homocyclic organic compounds. I think you are clear with homocyclic part. In the cycle, all will be carbon atoms. Again, alicyclic aromatic. Alicyclic in the sense, these compounds properties will be similar to aliphatic compounds. The only difference is aliphatic will have open structure, alicyclic will have closed structure. That is the only difference, but all properties will be similar to what? Aliphatic. Here the properties of these compounds will be similar to what? Will be similar to aliphatic compounds. Aliphatic compound means open chain compounds. Okay. Now when you take aromatic compounds, these have a pleasant smell called aroma. They have aroma. In Greek language, aroma means pleasant smell. Okay. The word aroma itself means pleasant smell. Greek language, aroma means what? It means a pleasant smell. So these cyclic compounds which have pleasant smell, they are called aromatic compounds, and of course they have alternate single and double bonds present. Okay, have aroma, and apart from that they have alternate single and double bonds. So this is the basic difference between alicyclic and aromatic. Alicyclic do not have any pleasant smell. Aromatic will have the smell. Alicyclic properties are similar to aliphatic compounds. Aromatic different properties, and they have alternate single double bonds. Okay. Now I'll give you some examples. With that you will be clear with alicyclic and aromatic. Okay. Okay. So here I got some examples. Let us classify these organic compounds. Okay. So if you see the first one, it's cyclopropane. Okay, so how can you classify it? Like you can see it's a closed structure, and if you see the atoms that are connected in the cycle, all of them are carbon atoms, isn't it? Similarly, in the case of cyclobutane also, the atoms in the cycle, the atoms in the ring, they are nothing but carbon, right? Even in the case of cyclohexane and also cyclopentane. Okay, so let us try to categorize them. The first point that I can write is here, all of these are cyclic compounds because they are having rings. Okay, and how many rings are present in all these given examples? One ring is present, so all of them can be considered under monocyclic compounds. Okay, now in the ring all the connecting atoms are carbon atoms, so we can consider them as homocyclic compounds. So in homocyclic, if you see here, there is no alternate single and double bonds. So these come under what? Alicyclic compounds, because their properties will be similar to what? Aliphatic compounds. Like we know about propane. Now here is cyclopropane. Propane, cyclopropane. What exactly is the difference? Only the structure. Propane is open, cyclopropane is closed, but properties will be similar. Okay. So I hope you have understood the first category of homocyclic compounds, that is alicyclic compounds. Okay. Now we will see some other examples. Now let us have a look at these compounds. See the first example, which is benzene. Okay. So how can we classify this? The first thing I can see is it is cyclic compound because it is having rings and one ring is present, so I classify it as monocyclic. Now in the ring, what are all the connecting atoms here? All the connecting atoms are nothing but the carbon atoms, isn't it? So I classify it as homocyclic compound. Okay. Now if you see, we can identify the alternate single and double bonds, isn't it? Let me mention it here. This is single, double bond, single, double bond, single and double bond. So alternate positions we have single and double bonds. If that is the case, what do we call them? We call them as aromatic compounds. In the aromatic compounds, again we have two types, benzenoid and non-benzenoid. So I'll just mention and note a point here. What is benzene? You know hexagon, right? So with a hexagon, if you have alternate single and double bonds, that is called benzene. Okay, so this can also be represented like this. Instead of keeping alternate position single double bonds, we can keep a circle in it. So this is also called benzene. So if you see the example one, it is having benzene. So what kind of aromatic compound is this? This is benzenoid organic compound. Okay. Now similarly, let us try to understand certain points about example 2. So if you see example 2, this is also cyclic because rings are present and two rings are present. So this is bicyclic compound. Okay. And if you see within the rings, we are having all carbon atoms. Different atom is not present, like oxygen, sulfur, such kind of atoms are not present. All the connecting atoms are carbons. So this is also an example of homocyclic compound. And what else can we understand from this? Is it aromatic or alicyclic? It is having alternate double and single bonds, so it comes under aromatic. Now if you see its structure, it's like two benzene rings connected, right? This is one benzene ring, this is another benzene ring. It's like two benzene rings connected. So benzene kind of structure. So this also comes under what? It also comes under benzenoid aromatic compound. Okay, so I hope you have understood the second category of homocyclic, aromatic, and in that benzenoid. Okay, so let us have a look at some other examples. So if you see example 3, we can see a ring in it. So this is an example of cyclic compound, and we can see one ring in it. So this is a monocyclic compound, and the connecting atoms in this ring are what? These are nothing but carbon atoms, right? All carbon atoms are connected in the ring. So this is homocyclic. Remember, homocyclic compounds are also called carbocyclic compounds. Okay, because carbon is the connecting atom. Okay, now so double and single bonds are present, so it's not alicyclic. It comes under what? It comes under aromatic compound. And what kind of aromatic compound? Does it represent anything like benzene? Hexagon, alternate single double bonds? It's not hexagon, right? Benzene means it must be a hexagon geometry. If you and hexagon has 6 sides. Let us look here. 1 2 3 4 5 6 7 7 sides are there. So it doesn't represent a benzene kind of structure. So it comes under non-benzenoid aromatic compound. So tropolone comes under non-benzenoid aromatic compound. Now let us see the other example, example 4, which is azulene. You can see this is also cyclic, and how many rings are present? Two rings are present. So this is bicyclic compound, and all the connecting atoms in the rings are what? They are nothing but carbon atoms. So this is also what? Homocyclic compound. Also you can call it carbocyclic. Okay, and what kind of homocyclic? Double single bonds are present, so this is aromatic. And what kind of aromatic? Benzenoid or non-benzenoid? If you see, there is nothing like benzene structure, so this is non-benzenoid aromatic compound. I hope you are clear with the homocyclic classification. Okay, homocyclics are classified into alicyclic, aromatic. Again, aromatic are classified into benzenoid and non-benzenoid. Okay, now we will see heterocyclic compounds. So now we'll study about the second category of cyclic compounds, that is heterocyclic organic compounds. Hetero means different atoms. Like if you take the ring, apart from carbon atoms, we also find some different atoms like sulfur, oxygen, nitrogen, such kind of compounds. Okay. So here in the ring, different atoms are also present. So what does it mean basically? When you take a ring, it consists of carbon atoms, also some other atoms. That is the meaning of this heterocyclic. Okay. And here also we classify it into two categories. So alicyclic, heterocyclic, alicyclic, heterocyclic. That means it's a heterocyclic compound, but properties will be similar to what? Aliphatic compounds. And then aromatic heterocyclic compounds. That means these are heterocyclic compounds and properties similar to aromatic compounds, like they have alternate single double bonds like that. Okay, like what we have discussed under homocyclic, the same way, but here hetero, different atoms are also present in the ring. Now I'll give you some examples and then we'll try to identify what kind of compound it is. Okay, so let us have a look at these compounds and let us try to identify what kind of compounds are these. Okay, so if you see here the all four examples, let us include one more example here. Let me take a hexagon but with different atoms in it. Okay, so this is 1,4 dioxin. Okay, so if you take these 5 examples, they are all cyclic compounds first of all. Okay, and what kind of cyclic compounds? All are having one ring, so all of them are monocyclic compounds. And if you see within the cycle, within the ring, we also find some different atoms. Like for suppose if I take piperidine, so the ones which I'm highlighting with green color, they are all carbon atoms. So in the hexagon, we should have 6 carbons, but here only 5 carbon atoms are present, and the 6th carbon place we are having some different atom, nitrogen. Similarly, if you say tetrahydrofuran, in the pentagon 4 carbons are present and the other carbon place we have oxygen atom, so different atoms are present. So what kind of cyclic compound is this? This is heterocyclic compounds, and all these heterocyclic compounds properties will be similar to what? Aliphatic compounds. So these are called alicyclic heterocyclic compounds because properties are similar to what? Aliphatic compounds. Okay, now I'll give you some other examples. Now let us have a look at these compounds and let us try to classify them. Okay, so if you see all these 5 examples like furan, thiophene, pyrrole, pyridine and quinoline. Okay, so all these compounds are having rings, so these are cyclic compounds, and all of them except example 5, they are having one ring in them. So example 1, 2, 3, 4, they are monocyclic compounds, and if you take example 5, 2 rings are present, so this is bicyclic compound. And within the ring we find some different atoms, isn't it? Like if you take example 1, it's a pentagon with oxygen, then example 2, pentagon with sulfur, then pentagon with nitrogen, hexagon with nitrogen, then example 5 is actually naphthalene but with some different nitrogen atom in it. Okay, so different atoms are present in that, that means carbon along with other atoms, so this is heterocyclic compound. Okay, now if you see we have alternate double and single bonds, so what kind of heterocyclic? This is aromatic heterocyclic, aromatic heterocyclic compound. Okay, now if you take 1, 2, 3, they don't represent the benzene, so they are non-benzenoid aromatic. And if you take example 4 and 5, they represent benzene kind of structures, so they are benzenoid aromatic heterocyclic. Okay, if you take 1, 2, 3, so this is a sub classification under last point. 1, 2, 3 are non-benzenoid, aromatic, heterocyclic. If you take 4 and 5, they represent benzene kind of structure, so they are benzenoid, aromatic, heterocyclic. So this is all about classification of cyclic compounds. Okay, so I'll just recollect once again the flow chart so that you will be perfectly clear. Okay, so how did we classify the organic compounds? I'm just recollecting the flow chart once again. If you take organic compounds, they are classified into two types based on the structure. So if it is open chain, that means it doesn't have any cyclic structure. If it is closed chain, it will have rings in it, closed structure. Okay, open chain compounds are also called what? Acyclic compounds, or they are also called aliphatic compounds. Okay, and closed chain compounds, they are also called cyclic compounds, and these are further classified into how many types? Homocyclic, that means in the ring all carbon atoms are connected. Heterocyclic, that means in the ring apart from carbon the other atoms are also present. So these two, homocyclic, heterocyclic, in both the cases again there are two types. Okay, one is alicyclic where properties will be similar to aliphatic. The other is aromatic where there will be alternate single and double bonds. In aromatic we have again two types, depending on what? Depending on the benzene resemblance. If benzene resemblance is there, they are called benzenoid structure. If there is no resemblance with benzene, then they are called non-benzenoid. So this is all what we have discussed so far. Now we'll see the second classification of organic compounds, that is based on the type of bond between carbon to carbon atoms. So this time we will classify the organic compounds based on what? Based on the type of bond present between carbon to carbon. Like whether single bond is present or double bond is present or triple bond is present. So based on the type of bond present between carbon atoms, organic compounds are classified into two types. Okay, so first category, saturated organic compounds, and second category, unsaturated organic compounds. So saturated organic compounds, in the sense there will be single bond between carbon to carbon. Okay, and unsaturated means there will be multiple bonds between carbon to carbon. See, multiple bonds in the sense what? It can be carbon to carbon double or it can be carbon to carbon triple. Can we have carbon to carbon 4 bonds, quadruple bond? See, if you imagine carbon to carbon 4 bonds, it's not possible, because if you take carbon to carbon 4 bonds, what happens? So valency is satisfied and that must result in C2 molecule. So in reality, do we have any existence of C2 molecule? No, right? So C2 molecule do not exist. That means it is unstable. So that's the reason it will not exist. That means this 4 bonds between carbon to carbon is not possible. Multiple bonds means either double bond or triple bond, not more than that. Okay. So saturated means single bond, unsaturated means either double or triple. Okay. So carbon to carbon single bond compounds, they are called generally alkanes, and carbon to carbon double bond compounds, generally they are called alkenes, and carbon to carbon triple bond compounds, they are generally called alkynes. Okay. So here ane stands for single bond, ene stands for double bond, and ine stands for triple bond. Okay, alkane, alkene, alkynes, one more important point, they are all a part of hydrocarbons. That means they have only carbon and hydrogen. So alkanes, alkenes and alkynes, they are all part of what? Hydrocarbons. That means they have only carbon and hydrogen atoms in them. What if it is saturated and having some other elements? They are called derivatives of hydrocarbons. Like for suppose if I take chloromethane. chloromethane, methane is CH4, it has only carbon and hydrogen. If I take chloromethane, chlorine is also present, different atom is also present. Then it comes under derivative of hydrocarbons. Okay. Now I'll write some examples and try to understand like it comes under saturated or unsaturated. Okay. So let us observe these two examples. The first one, ethane. Okay. So if you see carbon to carbon, we have what kind of bond? We have single bond. So this comes under what kind of organic compound? It's a saturated organic compound. Now if you see the second one, carbon to carbon, we are having extra bonds, isn't it? So one bond is enough for connectivity between two carbon atoms. So the extra one, this is your extra bond. What is extra bond here? Pi bonds are nothing but extra bonds. For two carbon atoms to connect with each other, one bond is enough. Two bonds are not required, but to satisfy the valency here, double bond is formed. So that extra one, other than one, the remaining all pi bonds are taken as extra bonds. So when extra bonds are present, it comes under what? It comes under unsaturated organic compound. Now let me take one more example. I'll take the same ethene molecule, but I'll just substitute one hydrogen atom with OH group, alcohol functional group. So what do we call this? This is called vinyl alcohol. Okay. Now this is saturated or unsaturated? Double bond is present here. So it comes under unsaturated organic compound. Now let me take one more example. I'll take the same ethene, but I'll just replace one hydrogen atom with one aldehyde group. So what do we call this? This is called acraldehyde. Okay. Now here also if you notice, there is a double bond between carbon to carbon. So this also comes under what? This also comes under unsaturated organic compound. Okay. What will be the IUPAC names of example 3 and example 4? Like you can take 1, 2. What will be the IUPAC name? 2 carbons eth and it is double bond at one position. So one position ene and one position alcohol. So one ol. What will be the IUPAC name of example 4? I'll just write it out here. 1, 2, 3 carbon atoms. So this is prop, second position double bond and first position aldehyde. Okay. Acraldehyde is a common name and prop 2 in 1 all is the IUPAC name. Okay. So these examples will make it clear for you like how to classify saturated and unsaturated. If I take one more example here, example 5, I'll just take CH triple bond CH. What is this? This is ethyne molecule. Okay. What do you see here? We see triple bond here. That means extra bonds are present. So this is also example of what? Unsaturated compound. I hope you are clear with this classification. Now we have one last kind of classification, that is depending on the functional group. Okay. So this time we are classifying the compounds depending on the functional group. Okay. So this is based on the functional group present in the given compound. So what is functional group basically? Functional group, the name itself is giving you the answer. It's a group of atoms which decides the function of the organic compounds. What is this functional group? It can be a single atom or it can be a group of atoms which determine the chemical properties of the organic compound. That decides the function of the organic compound. So that is how it is named as a functional group. Okay. So like which functional group is present in the given compound? According to that, we classify the organic compounds like, alkene family, alcohol family, acid family, like that. Now I'll just write different functional groups and the class of organic compounds. Okay. I'll just write it here. Functional group that is present and the class of organic compound. Okay, so first I'm just taking double bond between carbon atoms, so it comes under alkene class of compounds. So these are also called olefins. Okay, because in most of the oils we find double bonds. Now I'm taking triple bond between carbon atoms, so these are called alkyne compounds, and these are also called acetylens. Acetylene class of compounds. Okay, now when you take carbon single bond, these are called what? These are called alkane class of compounds, and these are also called paraffins because they have very less reactivity. Param means little, affinity means reactivity. They have very little reactivity, so they are also called paraffins. Now we'll see the remaining. Like if I take fluorine or chlorine or bromine or iodine, which are called halo compounds. Okay, so if I take halo functional groups, that means any halogen atom, they belong to alkyl halides family. Okay, now if I take hydroxy group, OH is called as hydroxy group. So if you find hydroxy group in the organic compound, they come under which class? They come under alcohols family. Okay, that means they are alkanols family. Okay, now when we take ether, what is ether? Oxygen connected to the chain. Okay, so this is ether functional group. So if we find ether functional group, it belongs to ether family, or we can call it as alkoxy alkane family. Okay, next we will see aldehyde, that is C double bond OH. This is aldehyde functional group. So then it belongs to which family? Aldehyde family. The class of organic compounds is also aldehyde. It is also called alkanols. Okay, next is carbonyl group. So if you find C double bond O, the name of this C double bond O is carbonyl, and it belongs to which class of organic compounds? It belongs to ketones family. They are also called alkanones. Now C double bond O OH. So this is carboxyl group. C double bond O and OH. Together it is carboxyl group, and it belongs to which class of organic compounds? It belongs to carboxylic acid class of compounds, and generally they are called alkanoic acids. Now we'll take C double bond O X. C double bond O is carbonyl, X is halogen atom. So this is actually called what? Acyl halide. C double bond by X is called acyl halide, and it belongs to which class of compounds? It belongs to acid halide class of compounds. This can also be called as alkanoyl halides. You can call them as acid halides or alkanoyl halides. Anyone is fine. Okay. Now C double bond O NH2. So the name of this group is amide, and it belongs to which class of compounds? It's the same. It belongs to amide class of compounds, and generally they are called alkane amides. Now we will take acid anhydride, C double bond O, C double bond O. Okay, this is called anhydride group, and if this functional group is present, what do we call that class of compounds? They are called acid anhydrides, or they are also called alkanoic anhydrides. See, anhydrides, what does it mean? It means no water. That is the meaning of anhydride. Okay, like if you take two carboxylic acid functional groups, let me take C double bond O OH, and one more C double bond OH. So if I remove OH from one acid, H from another acid, that means H2O. I'm removing H2O. Now connect these two parts, first part and second part. What will you get? You'll get this anhydride, C double bond O, C double bond O. Okay. From the acids you are removing H2O. That's why it's called acid anhydride. Next I'll go with ester. What is ester? C double bond O R. Okay. So this is our ester. If ester functional group is present, the class of compounds is also called ester, or we call them as alkyl alkanoates. They belong to alkyl alkanoates family. Okay. If you find C triple bond N, that is cyano group, the class of organic compounds is called cyanides, or they are also called nitriles. In a simple way, they are called alkane nitrile family of compounds. Now if you take isocyano group, okay, so this is isocyano. What is the difference between cyano group and isocyano group? If you see here, to the main chain carbon atom is connected, and here to the main chain nitrogen atom is connected. Okay, and all the three bonds here, they are normal covalent bonds. If you see here, the triple bonds present between nitrogen and carbon in isocyano group, the lower two are covalent bonds and the top one is coordinate covalent bond. Okay, so that's the difference. If nitrogen atom is connected to main chain isocyano, and what do we call those class of compounds? They are called isocyanides. If cyano group is connected, cyanides. If isocyano group is connected, isocyanides. If NO2 is connected, this is called nitro, and we call them as nitro compounds, or we call them as nitro alkanes. This is the class of compounds. And if NH2 is present, NH2 is called amine group, so they are called amines. Okay. If NO is present, they are called nitroso compounds. Okay, and this is also nitroso. So how is the bonding in nitro group? So nitrogen will be connected to the main chain. There will be double bond with one oxygen. There will be coordinate covalent bond with another oxygen. Okay. And how will be the bonding in amine? Nitrogen will be connected with the main chain, and with two hydrogens there will be a single bond. Okay. So according to the functional group present, we just consider them into different class of organic compounds. Okay. So this is all about classification of organic compounds. First we started with classification depending on the structure, then depending on the type of bond between carbon atoms, now according to the functional group present. So this is all about the classification of organic compounds. Hope you all have understood. So if there is any doubt, please mention in the comment section. I'll try my best to clear your doubts. So as of now, thank you so much.